This lesson is on fractional coefficients. If you take a look at the equation above, what it really means is 1/9 times x squared minus a 1/6 times x minus 1/2 is equal to 0. And as I've stated in your notes, the way that you do this is you find the least common multiple of your three denominators, and you'll multiply everything by that number. So in this case, the least common denominator is 18. So when I multiply this by 18, this times 18, this one, and this one, that cancels. This becomes 2x squared. This becomes negative 3x. That becomes 9, equal to 0. From here, we know how to solve this. We can just factor it. And we can check. It's negative 6x plus 3x. That works. And we set each of these equal to 0. There's your solution. Although it looks a little different because you have fractions on both sides, and you have a lot of things going on here and fewer things here, you still find the lowest common denominator. In this case, it's 12. So I'll multiply this by 12. This gets multiplied by 12. And this gets multiplied by 12. I can't forget to distribute the 3. And now really we just solve for x. I'll bring 3x over here. I'll add 36 to the other side. This is called a mixture problem because we're mixing some percent of a solution with another percent of a solution to obtain a different percent of a solution. I think the best way to approach this problem is to set up a chart. So we have an 18% solution, we have a 10% solution, and then we have our final solution. And what I like to do is say how many milliliters of the solution times the percent of the acid, and that will equal the milliliters. So it asks us how much, so that's going to be x. Our percent acid is 18%, so 0.18x. On the next one, we have 360 milliliters and 10%. And then finally, we have this final solution, which will be the 360 plus the x we don't know. Our percent will be 0.15. So it's 0.15 times 360 plus x. So what we do to set this up is we add these values together. 0.18x plus 0.10 times 360 has to equal 0.15 times 360 plus x. Now, this is still a fractional coefficient because these are all fractional values. We can multiply each one of them by 100. And from here we simplify. I'll come up here. 3x is equal to 1800. This last problem is a work problem because we've got two pipes and they are doing some kind of work filling a tank. I actually set this up a little bit differently than the mixture problems. So I'll say, okay, I'm going to let x be the number of hours that A works. And it tells me that A was turned on at noon, B was turned on an hour and a half later. So B works 1.5 hours less than that. So x minus 1.5 is the number of hours that B works. Then I say, okay, well, A will do 1/8 of the job in 1 hour. And the reason is because it takes 8 hours for A to fill the tank. So in 1 hour, it'll do 1/8 of the job. B will do 1/12 in 1 hour. So in X hours, A does X times 1/8. And in X minus 1.5 hours, B does X minus 1.5 times 1/12. So now all I have to do is add them together. And in the end, one tank was filled. So this is now fractional coefficient. We need a common denominator. In this case, it'll be 24. This means 27/5 of an hour, or we can say it's 5.4 hours. So that means A has worked 5.4 hours. And it starts at noon, so it's finished 5.4 hours later. What I do is I put in my calculator 0.4 times 60, and I find out that that's 22 minutes. So the tank is full. At it's 24 minutes. At 5:24. because it started at noon. 5 hours later, it's 5 p.m., 24 minutes after that.